Okay, it's 12:30, so let's get started here. Assignment number 4 is due October 28th at noon. We've spent some time, starting about 1:20 today, discussing problems 3 and 4 in the assignment. Today we will finish our introduction to LyX, and then we will start talking about Beamer. And I briefly mentioned that before, that Beamer is basically a package that can be used with LaTeX and LyX to do what you can do with PowerPoint. Today I am using a new webcam. Hopefully everything will work out fine. So you might remember during our last class I used the weird webcams that are always in this room now. We never had that before this semester. One position there and one position over there. And I used one of those webcams last time and found out I couldn't get it to work with my USB cable that I normally use with my webcam. And that made me think, oh, the whole problem was with the USB cable, not the webcam, my old webcam. However, when I've done some tests with this new webcam, I haven't been able to duplicate that there is a problem with the USB cable. So we'll just see how things go. Obviously, if this recording doesn't work today, it has to be the USB cable. So anyway, are there any questions before we get going here? Okay, so last time we were talking about LyX and bibliographies, and it takes us to about approximately page 30 in the notes. Actually backtracking a little bit. So there's one last thing I wanted to talk about with respect to doing bibliographies with LyX. Now, if you remember from last time, there is something called BibTeX. And BibTeX allows you to basically automatically create bibliographies in a LyX or LaTeX file. And BibTeX is basically a file format, .bib. And these files can be read in a number of different citation management software packages. And the one that we looked at in class was one called JabRef. And so let me get there. So if you remember, each of these rows represent a particular reference I want to make in my LyX document. And in order to get these references in there, we talked about how you can simply type the author, type the title, type the journal, if this is a journal article, and so on. You can simply type these references in there. And you need to make sure that you have a BibTeX key here that gives a unique identification to this particular reference you're going to make. And this is what you use in your LyX document to refer to the reference in this .bib file. Also, I mentioned how basically a BibTeX file is actually just a plain ASCII text file, and where there's a certain coding format that you use to get the references into it. So essentially what JabRef allows you to do is type in this nice little format here, and it automatically converts it to the actual code format that is used then by LaTeX or LyX. And so this code format, for example, at article means the journal article. We have the BibTeX key. We have information about the author, the title, and so on. So one way, again, to then get the BibTeX code is to simply, again, type it in this format here in JabRef. Let's talk about an easier way to get the BibTeX code, where you can simply just copy and paste it into the file. So I'm going to come over here to Google Scholar. So there's a number of different databases or search engines online that allow you to find different citations or different works out there that you want to examine further. And Google Scholar now is probably the leading tool out there. And so if I just, for example, type my name into Google Scholar and do a search, you can see a number of different publications that I have. The key thing is, if we look at this very first article that's given, journal article that's given here, this actually is the first paper I published for my dissertation. The key thing for us right now, or for this class, is this import into BibTeX link. So if I click on that, guess what? You get the exact BibTeX code. So what I can do is copy this, come over to JabRef, hit the plus sign for a new entry, article, BibTeX source, and then just paste that in there. If I look at now the required fields tab, you can see everything's nicely organized, and you are done. The cool thing about this is that there's going to be less of a chance that you're going to make an error, like accidentally type page number wrong. Now, Google Scholar is not 100% perfect, so you should still make sure that the reference is listed correctly. But I think, at least through my experience, there's going to be less errors if you just simply take what comes from Google Scholar. Okay. Are there any questions? Okay, so that takes us then to page 35 in the document. Also do note that I, in addition to buying a new webcam, since we last met, I bought a newer version of PDF Annotator as well. So if my notes look a little bit different here, that's, at least the setting looks a little bit different here, that's why. Let's see. Okay, what about an index? Suppose you have, obviously an index is only really useful if you have a large document, and that makes it easier for people who are reading the document to easily find things. To do an index in LyX, really simple. Insert list table of contents and index list. That will insert your index, but that's not good enough because, of course, now you need to say, well, what do I want in the index? How can we do that in LyX? Let me make this a little bit bigger. There we go. Okay. So let's say for some reason I wanted to have an index entry for binomial. So what that means in my index, you're going to see binomial, and you're going to see the page number where it occurred in the actual document. All this stuff is automatically generated by LyX. But you have to tell LyX, yes, I want to have binomial in the index. So the way that you do that is you position your cursor around binomial, and you come up here to insert index entry, and notice it guesses what the index entry would be based upon where you had placed your mouse, simply. But of course, you can edit it, so I can make it a capital B for binomial instead. That often looks better, and there I'm done. If I want to, I can minimize that, so it just kind of appears smaller inside the document itself. Okay, so now when you compile your document, an index will be created, and you will see everything referenced there. Do note, though, that sometimes, this was at least with earlier versions of LyX, maybe it's not with the most current versions. Basically, I've been using 2.0.6 for a while, and just for this class, I've updated to 2.1 and 2.2. And what I've noticed sometimes with 2.0.6, or maybe it was 0.3, I had to compile the document more than once to make sure the index entries were updated correctly to the correct page numbers. And why does that happen? Well, it all goes down to how LaTeX approaches things like this. Same thing with bibliography entries. In LaTeX itself, when you first compile a document, what's going to happen is that LaTeX, or MikTeX, is going to create some additional files. We saw those before, like a .aux file. And in those files, it puts important information that it will use. But the first time through that compiling, it won't know to go to that file to find it. It's just basically looking through your document, finding the important things, put into these auxiliary or these extra files. and then if you compile your document a second time, that's when it goes and looks to say, oh, you have a .aux file. I'm going to go there and find some information and use that information in creating the PDF. So just be forewarned that you might have to actually compile your document, create that PDF more than once to get everything the way it should be. Any questions? Okay, so page 36. So we talked about, let me make this a little smaller. There we go. So we've talked about style files, .sty files, when we were talking about LaTeX. We also talked about document class files as well, .cls files. If you remember with the biometrics journal article that I had, we had to use a special class file with it to get into biometrics desired format. Well, let's say you want to use a .sty file, style file, with LyX. How do you do it? Exactly like you would with LaTeX. You simply put the .sty file in the same folder on your computer where you have the LyX file, and then in the preamble, you say /use package, and then give the style file name. That's it. With a document class file, it's a little bit more difficult, but it's not too bad. I give some directions here of how to use it. You can put the .cls file again in the same folder where you have the LyX file. But you also have to go one step further, and you need to create what's called a layout file. These layout files are special for LyX, not necessary for LaTeX, just special for LyX itself. And I give some directions here how to do it. You can please see those directions on your own. At least in the assignments, you're not going to have an occasion where you need to do this. But I see further down the line, especially if you're going for a PhD, this will come in handy. Speaking of a PhD, with a PhD, you're going to need to do a dissertation, and these dissertations need to be in a particular format that the university requires. Well, the math department has put together some nice LyX files to help you get that format correct. They also, if you remember, they have LaTeX files too. Well, they've done the same thing with LyX. Then lastly, some final comments in this section. Hopefully all of you have installed LyX on your computer already and started playing around with it. You might have noticed that there are some additional LyX files that are automatically created, a .lyx tilde file in particular. This file is just simply a temporary backup file that LyX automatically creates. You can turn it off if you want to, if you don't want to have backup files automatically created, but obviously there are times where they can be useful. Now, a problem with LaTeX and LyX is that the text in a PDF file on a particular line might actually extend over into the margin. So if you notice here in this document, notice how I have everything fully justified. All the text lines up on the same part on the left-hand margin. All the text goes all the way to the right-hand margin, and it ends right there. And that's what you typically see in more professionally created documents, rather than, let's say, ending here, maybe ending there, maybe ending there, and so on, where you don't have that right justification. Let me get my red pen. Okay. Well, to do this, what LaTeX does, it will often automatically hyphenate words. It will also position words on the line in a way using its algorithms such that you do have that nice right margin. But unfortunately, their algorithm doesn't always work. And while I don't have a good example here, unfortunately, you will see sometimes maybe this part right there, especially when you're dealing with web addresses and also file names that might be long, where it doesn't necessarily know how to hyphenate a file name, because file names don't necessarily contain full words. You might just see part of that just keep on going in the right margin. How can you fix it? Well, there's a few ways. There's a command that you can put in the preamble corresponding to what's called the tolerance. This tolerance is, and you specify a particular number from 0 to 10,000. What that corresponds to is how tolerant will LaTeX be in determining where to break a line. The higher the number, the more likely you won't have that text go over to the right margin. However, when that happens, you might get a line of text that looks like this. Suppose I have a word here, I have a word here, and I have a word there. While it's correctly justified, you have huge spaces between words. So basically, the way most people just approach it is you play around with that number if you have problems. If you don't have problems, just leave it alone. Another thing that some people do, which I don't like, but sometimes it's the only way you can do it, is that you can actually just simply change your wording. So change, don't use the exact same words. Try to say it more concise, or just replace a word with a synonym, so that now the number of characters in each characters is different, and that might cause LaTeX to handle it correctly. Unfortunately, that does happen sometimes. Lastly, LyX is great for tracking changes. So we've talked about tracking changes a little bit. I mean, in fact, the assignments that you've handed in to me via Word files, I track my changes so that I can give comments back to you. But typically in an environment, let's say outside of school, often you're working with teams of people. You're working on the same document together, and to understand what somebody maybe made a modification to the file versus what you're modifying the file to be, is very useful to always have track changes turned on so that you can see who made what change. And then if you agree that the change is good, you accept the changes. So for example, here's part of my book. Let's see if I can make this a little bigger. This is my analysis of categorical data book that I completed a few years ago. As I think I mentioned before, my co-author was based at Simon Fraser University in the Vancouver area in British Columbia. And so we needed to use LyX comments to communicate with one another, but we also needed to track our changes. And the way that we did that was we turned on the toolbar corresponding to review. And the toolbar, as you see where my mouse is, it's located right up here. And if I turn on track changes, you have the same thing happens as you would expect in Word. Now you see everything highlighted in blue and underlined, meaning, hey, that's a change that I just made to my document. And so you can see how for Tom, when he was doing stuff, he had his changes tracked in kind of a pink color. I had my tracked in a blue color. And when we get to the actual text, you can see how, oh yeah, I just added this sentence here. This was the preface of our book. And you can see all the changes that we did. And if we agree that the change was good, then we right-click on it, accept change. If we didn't like it, reject it, and so on. And there's a number of different options of what you can do corresponding to this toolbar up here about how you track your changes. Very, very, very useful tool. Are there any questions? Okay, let's move on to the next section. We're going to talk about Beamer. Okay, so Beamer basically allows you with LaTeX and LyX to create presentations. These, unlike PowerPoint, where you have one .ppt file, and that's where you make that's where you type your presentation, all the text in your presentation, and then when you want to actually view it as a presentation, you click on a button and your screen goes full in terms of your PowerPoint presentation is fully on the entire screen, and then you can use a mouse to simply click through it. Well, here with LyX and LaTeX, well, we'll just talk about LyX here. You're going to create a LyX file, just like what we just got done doing, and then you're going to have to compile it. That compiling creates the PDF, and you present from a PDF. If you go to, for example, any statistical conference out there, you will see PowerPoint, and you will see Beamer used. Depending upon the presentations that you go to, correspond to how much you see people use PowerPoint versus Beamer. So if you go to a presentation that has some mathematical expressions in it, like equations, formulas, and stuff, you're going to be a lot more likely to see people using Beamer than PowerPoint. If you go to instead a presentation that's maybe talking about current things happening in statistics, or like here's an example from the last joint statistical meetings. There was and I might have mentioned this in maybe it was the Alpha Seminar, of course, that some of you are taking. There was a whole session on ethics. So a session meaning that there were like 4 or 5 presentations on ethics regarding to statistics. Now in that case, you wouldn't expect as many equations and stuff. And so I have those corresponding presentations that the people gave, and they're PowerPoint files. So, PowerPoint's great. I like PowerPoint, but there are some issues with using PowerPoint, in particular with equations. I think just to save time, I won't get into all those issues here. If you're interested, I have laid them out here. And if you want, you can read them. So in terms of then alternatives to PowerPoint, the one that's most predominantly used is using LaTeX-based alternatives, where by far the Beamer package is what's used. And this has been now about 10 years that this has occurred in statistics. There are other packages out there to do presentations, but you rarely see them anymore. So to begin here, similar to how I began the LaTeX section and the LyX section, we have a Hello World document here that is an introduction to doing these Beamer-like presentations. I should say Beamer-like, Beamer presentations, definitely. Okay, let me find my file. Fortunately, I accidentally closed it out. Let's see. That one. There we go. Okay. So here's my Beamer presentation file, or I should say my Beamer presentation file. This is the PDF created from LyX that use Beamer. And this is just to get us going here. Now, there are a number, like PowerPoint, there are a number of themes that you can use that control the colors, that controls the placements of text, that control where the bullets are located, what the bullets look like, and so on. There's a number of different themes out there. This is probably the most often used theme that you'll see. Or at least it has been more so in the past, and I think people now are broadening out and actually trying other themes, but this is the one I still see most often. And in fact, when our department chair, Bert Clark, when he was interviewing for the position here about 3.5 years ago, this is the theme that he used for his presentation that he gave to the department. And at the top, you'll see an outline. This is a common theme in Beamer created presentations is that the outline for the entire presentation stays at the top so that you can figure out, or so that people in the audience can easily figure out where you are at. A very, very, very useful tool. There is not and this is done automatically. There isn't an automatic way to do this in PowerPoint, or at least up to PowerPoint 2013. I haven't checked in 2000 with the latest PowerPoint. So a very, very useful tool. Obviously, this is just a simple title slide here. At the bottom, you have basically a footer that you can put information. This is the default. It puts the title to remind people, hey, this was the title of my presentation. If you forgot it by now, there it is again. And also, if you don't remember what my name is, hey, there's my name. You'll remember it throughout my talk. Now, if you notice, what's more of a transparent manner here, you see some icons. These are automatically created by Beamer, and simply they allow you, if I simply click on one, there we go, it allows you to go back and forth in your presentation. And you can still use your mouse like you would normally in PowerPoint, or you can use like the Enter key or the space bar, but these are other tools that you can use. And some of them will actually, let's see here. No, I know it should, but unfortunately it's not working right now. Actually bring up an outline of your presentation. Okay. Excuse me. Now, when you give a presentation with a PDF like this, you don't just simply stay in Adobe Acrobat or whatever PDF viewer you're using and give the presentation like this. Rather, you always need to go to full screen mode, and there you go. Okay, and that's how you give your presentation. You can have, so I have this title slide. You can have an outline automatically created for you, and then notice how once I get to the main part of my my document here, I have a title for every page there, and that's essentially automatically created for you. Okay. Just a second, I want to make sure. So we're on page 5 of the notes. Okay. And in PowerPoint, each page is referred to as a slide. When you're using Beamer, rather than a slide, they're called frames. Okay? So here's a frame. If I page down, there's a frame, and there's another frame. Now, there's also something called slides in Beamer. These are different from frames. I will talk about those a little bit later, but slides and frames are different. A frame, though, is equivalent to a slide in PowerPoint. Hopefully that's not confusing. I guess I do talk about that now. I apologize. When I was going over this earlier today, it's like, oh, I didn't talk about the difference of frames and slides until later in the notes, but we can do this now. Okay. Let me get to the right spot. Okay. Now, one aspect of PowerPoint is that you can do animations, meaning that let's say you have 3 bullets on a PowerPoint slide. You can show the first bullet, talk about it. And when you're done talking about it, you click on your mouse. Oh, the second bullet comes in. Hopefully, it doesn't come in like really weird, with some weird animation. Rather, hopefully, it just simply appears so that you're not. I remember when PowerPoint first came out, which is probably none of you do, but I think all of you know what I'm talking about when you have these really weird animations that you can do. And back in like PowerPoint 95 or whatever it was, people chose the random animation, and oh wow, that was cool for like the first 6 months. People did that, and then after, like, oh no, that's distracting. And so most people just simply have bullets appear one by one. And what I mean by appear is that if I click on my mouse here, okay, something just appeared, rather than come in from the right, come in from the left. Anyway, so you can do animations with Beamer. The key, though, is that the way that Beamer does the animation is, what's the word? I have the word there. It's not doing the animation like PowerPoint. I'll just say it that way. There's a better word. Unfortunately, I can't think of it right now. But the way that Beamer does it is it simply creates two. So you saw the animation that I have. I have a bullet, and then I had 2 bullets that come below it. And the way that it's done is it actually creates separate pages in your PDF. So it's not like the PDF file itself has some kind of animation system in it. Rather, it basically, Beamer mimics the animation process by creating multiple pages in the PDF. So up here, I know it's small, but I can't make it any larger. If you notice where my mouse is, we see the page, we see the frame number. So I am on frame 4 of my Beamer presentation. In parentheses, what we see is information about the slides. In other words, the pages. So this tells me I'm on 4 of 14. There are 14 separate pages in this PDF document. In Beamer's terminology, this means there are 14 slides. I'm on the 4th slide out of 14. This is frame 4. Now when I go down 1 to have the animation occur, look what happens. I am now on slide 5 of 14, or page 5 of 14. So a page in the PDF document is a slide. I'm still on the same frame, though. I'm still in frame 4, but I'm on a different slide. That's the difference. Any questions about that? Okay. Okay, so let's take a look at the LyX document itself. So this is on page 7. That's kind of small. Okay, so here's the LyX document itself. The first thing that you need to do whenever you're creating a Beamer presentation is that you have to specify, oh, I want to use the Beamer package. How do I do that? I come up here to Documents, Settings, Document Class, and I choose Beamer. Now please make sure, though, when you choose Beamer, it's under the presentations part of all these document classes that are available to you, rather than, where is it? The articles part. Choose the presentations part, because we're doing a presentation. Okay? Let's see. So once you do that, what happens? Well, remember, the document class controls the environments that are available to you. Environments, some of them are located here on the left-hand side. So for example, I'm up here where it says Hello World. Remember that was the title of my presentation. And notice I am in the title environment. So I've had to actually specify that. Once I specify that, LyX, or I should, well, we'll just say LyX. LyX automatically creates then a title frame that has Hello World on it. It also will look, do you have author information? Yes, I do. I've specified that as an environment. Do you have, like where are you located? Or what it calls institute. Okay, yes I do. Department of Statistics, University of Nebraska-Lincoln. Now, do note, this is more of the finer things about using Beamer here, is that this institute environment where you say where you're from, very often, you want to, have that extend over more than one line. Department of Statistics, University of Nebraska-Lincoln, and I also have my web address. So you might be thinking, okay, to do that, all I need to do is hit enter, and then I, start typing again, make sure it's the institute environment, and so on. The problem is if you do that, LyX, I forget which one it is, LyX only grabs the first entry or the last entry in that institute environment. So that, for example, you might just see only Department of Statistics there. That's it. So you have to tell LyX, hey, wait a second, I'm not done. I just want some stuff moved down to the next line. And the way that you always do that in LyX, not just when you're working with Beamer, is that you use what's called a ragged line break. Oops. And so if you notice here at the end of these lines here, I have this little arrow there. That's just a way to designate, hey, I have a ragged line break. That's it. Let me also turn on something else here. Where is that? Notice it's different from an end of paragraph break. So how do you get that ragged line break? It's really easy. You can do Control-Enter on your keyboard instead of just Enter, or you can go Insert Formatting Ragged Line Break. Okay. There's also a date environment that you can put there too. If you don't put a date there, most Beamer themes will automatically put a date for you instead. Okay. So, speaking of themes, as I said here before, this is one theme that's available to you, just like how in PowerPoint you have a variety of different themes available to you. There are a number of different themes out there. The way to specify a particular theme is you come up here to Document, Settings, get into your LaTeX preamble, and do the command/use theme. And then there's a number of different names for themes out there. I'm using one called Warsaw. All these themes are named after particular cities. Well, how do you know what all the themes are? Well, in my notes here, I give you a particular web address that lists out a lot of the themes. I guess this is just one of those cases where somebody has a little bit too much time on their hands and they decide to actually create or create images that show all the different themes. Now you'll notice that these themes have names that are cities. Why? I don't know, but that's the way it is. There is not a theme called Lincoln though, but it's mainly big cities like Berlin. Now, I guess Ann Arbor is not that big of a city, but if you notice, it has the University of Michigan's coloring to it. You can change colors real easy, so you don't have to go with the maize and gold if you don't like it. Or not the maize and blue, right? That's for those of you who are Michigan, I think it's maize and blue. Blue maize. Yeah, it doesn't matter. But anyway, so you can use that to figure out various themes, and you pick one that you like. Just change what you have in your preamble, and look, do I like it or not? I personally don't usually use Warsaw. I usually use a different one. You'll see that in another example coming up. Okay, so we've already talked about the title frame. Let's talk about frames in general. So again, a frame is like a slide in PowerPoint. And if I go back to my LyX document here, if I just page down, you'll notice I have some frames. As you might expect, introduction, that's the title of the frame. That is what actually appeared right there as the title of the actual frame in the PDF. And as I keep on paging down, you can see I have other frames as well. And these just, correspond to what we were seeing in that PDF document. Notice how I've structured my document, similar to what we saw with that master-child example with LyX, and also we saw some examples with just plain old LaTeX. I use sections and subsections. So section 1, introduction. How do I do that? Again, I choose the section environment. Section 2, I have a subsection. Now, why is that important to do when we're doing a presentation like this? Well, take a look at, again, this outline that's on the top of each page. That corresponds to the sections and the subsections. So if I come down here to proposed method, or which one is it? Thank you. So when I go to the background here, now you see the subsections. It's just an extremely, extremely useful tool whenever you're given presentations like this. Because, have you ever been in a presentation where it's like, 25 minutes into it, you're wondering, how much longer am I going to have to be here? Well, if the author or the speaker has put, the corresponding outline there on each slide, you have a general idea. And so, right now it's like, oh no, he or she's just beginning. I'm going to be here forever. Or, if like our Department of Statistics seminars, let's say a speaker is at the 50-minute mark, which is the duration that you're supposed to stop at, and the speaker's, let's say, still in background, then you're in trouble. Because that speaker didn't actually practice the presentation. To realize that, indeed, they prepared for something much longer than what they actually had. So that's helpful. Also, there are tools that I will show you where you can have, in the lower right-hand corner, you can have the frame number that you're on with the total frames that you have available to you, always listed there. Again, an essential tool whenever you do a presentation so that people know, okay, I'm on frame 10 of 12. Okay, I only have 2 more frames. I'm not going to just leave this presentation and go. I can sit for the rest of it. More on that later. Okay, now let's talk about how to create a frame. And to do that, I'm going to simply create a brand new LyX file. So once I created this brand new LyX file, what's the first thing I should do if I want to use Beamer? Set the document class. Exactly. Because until I do that, I'm not going to have available to me the different environments that I need. And maybe I should have also said before. Notice these environments here. One of them is called frame. So I need to say Beamer. I'm using Beamer so I can actually do a frame. So document settings, document class, Beamer. Now I have access to the right environments. So let's come down here to frame and notice LyX automatically says, okay, I have a frame. So I'll just call it Title 1. Okay. And now I'm out of that frame title. Notice how you have that pink box. Well, it's not a pink box, but it's like that box that we saw with equations. We have a box there too. So I'm going to move over. Right, so I hit the right arrow. Then I'm going to hit enter. In order to tell LyX that I have content in this particular frame, I can't just start typing now. Instead, I need to come up here to where you see increased depth. So, just like how when you have like an outline, you have, let's say, the first level of an outline, you have the second level, you have the third level, and that's an organizational tool. Well, we basically have to do the same thing here. So I'm going to increase depth. Oops. First of all, I need to make sure I'm in the standard environment now. And I'm going to increase my depth. And look what happened. Now I have a kind of a pink left border there. And so let's say what you normally do with a presentation, you have a bullet. So this is bullet 1. If I enter, bullet 2. And if I hit enter, I get a third bullet, and so on. And notice how everything is still nicely structured within that left line there. That tells me everything is going into that first frame. Let's say I want to do a new frame now. What should I do? Well, hit enter. Notice how I am out now of that. Try that again. So I hit enter, and a new bullet was created. Well, what I want to do is I want to get out of that stuff that you see on that left-hand side, that line that's saying this is still within that frame. So to do that, I no longer, I remove that. I'm not saying that very well. Let me try this again. Decrease depth. So now I want to come out of it. So before I was increasing the depth, and now you can see how I'm out. I don't want a bullet out there, so now I remove the fact that I was using bullets by using just the default standard layout. Now to insert a new frame, insert frame. Oh, let me make sure I'm using the right version here. Yes, I am. Okay, let's try this again. There we go. That's what I need. Sorry. Let me back up a second here. So LyX has made some changes from 2.0 ways of using Beamer. So now using Beamer in LyX 2.1 and 2.2. I'm not as familiar with the 2.1 and 2.2 as I was with 2.0. Because some of these changes that they made are meant to make it easier for people to use LyX in Beamer. I can see that. It does kind of happen, but for those of us who were using Beamer before with 2.0, how to do stuff is not necessarily as intuitive as it was before. So let's try this all again so I can walk you through it. Okay, so now I hit enter. I have a bullet. I want a new frame. What should I do? Well, first thing I'm going to do is I'm going to decrease the depth so that I'm no longer inside this frame. So now you can see how I'm outside the frame. Also, what I'm going to do is I want just a standard text here. I'm not itemizing, meaning I don't want bullets because I'm not in a frame right now. And then lastly, what I have to do is I need to tell Beamer, hey, the end of that frame should occur right here. How do I do that? There's two ways. One way, hit enter. And you see the line there? That means I'm done. That frame's completely done. Another way to do it is insert. Oops. If I come all the way back up here, let's try it this way. Insert. Shoot. Just give me a second, sorry. Let's hit the wrong one. Edit, start new parent frame. And that will do the same thing. And it actually threw up the frame. key is you need to have what's called the end of frame marker, that horizontal line there, at the end of the frame. That's the key. In order to write these lecture notes, I had to teach myself these new changes. And I have to admit I was frustrated at times. I feel as though I have a good feeling for it right now, how it's done. But I do know from experience, if you don't have that end of frame marker there, you will run into problems. Either it won't compile, or you'll have stuff kind of bleed over to the next frame. If there's ever any questions, if you're having problems, of course, let me know and we can figure it out. Okay, so now I can come here and type a new frame. So title 2. And if I hit the right arrow to get out of it, enter. Again, what I need to do is increase the depth. Oops. Sorry. I need to say I'm in the standard text, increase depth, and now I can again start typing bullets as I was doing before. That end of frame marker is not always needed. So let me tell you that. So if you notice here, now this is back to my Hello World document here. I have a frame. I have the end of frame marker. I have another frame. I don't have an end of frame marker before I start that one. Why not? LyX automatically understands that you want to have an end of frame marker because you have a new section or subsection. Now, the thing that had confused me in the past is that you didn't need an end of frame marker before with LyX 2.0. Now, starting with 2.1, you do. So I hope that was, again, clear. Again, if there's any questions, please feel free to let me know. We've gotten to about 1:20. So what I want to do next is start talking about or continue our discussion of the next assignment. Okay. So problem number 3 here. The purpose is to give you more exposure to using LyX in a mathematical way, like a mathematical proof way. So what I basically want you to do is write up the mathematical proof for a confidence interval, for a population mean, the standard confidence interval, that t-distribution-based interval that all of you have learned about before. To help you out, though, I only want essentially one part of the normal proof that you would see in a mathematical statistics course. And that is, suppose, well, let me actually go back up here for a second. So here's the setup, and what you need for a confidence interval for a population mean. Y1 through Yn, these are random variables. They are independent random variables. They have a normal distribution with a mean of mu, a variance of sigma squared. We want a confidence interval for that mu. Here's the standard 1 minus alpha times 100% confidence interval for mu, that t-distribution-based interval. Notice how I'm being formal with my notation here. The random variables have capital letters. Observed values have lowercase letters, just like what you would expect in a mathematical statistics course. So these are observed values, not random variables. Now, what you would learn when you first see that derivation, typically an instructor goes through the process of showing that this quantity t here, again, capital letters, a random variable, this letter t there has a t-distribution. So, you work with a normal distribution, you work with a chi-squared distribution, you put them all together, and voila, you get this nice t-distribution that W.S. Gossett derived over 100 years ago at Guinness Breweries in Ireland. Anyway, what I want you to do is start with the fact that we know that this has a t-distribution, and tell me how you get to there using a formal mathematical proof. Let's do an example for a different confidence interval to let you know what I'm looking for. So I want a confidence interval for sigma squared now. Get my notes out. Okay. Does anyone know or remember what the standard formula is for a confidence interval for sigma squared? Meaning, I have sigma squared in the middle. What goes on the left side? What goes on the right side? Does anyone remember? Does anyone remember what distribution you're working with? Chi-squared, yes. Does anyone remember what would go on the right side? That's okay. N minus 1 times s squared. That s is a lowercase letter because it's an observed value. Divided by, let me remove that. Chi squared. 1 minus alpha divided, oops, hold on. The alpha divided by 2 quantile from a chi-square with n minus 1 degrees of freedom. On the left side, n minus 1, s squared, chi-squared quantile, the 1 minus alpha divided by 2 quantile with n minus 1 degrees of freedom. That's the standard formula that's used for a confidence interval for sigma squared. This all relies on y1 through yn to be distributed independent normal mu sigma squared. Does that look familiar? Okay. Don't ever use that formula in practice. It's bad. I know, it's kind of weird. This is the first one. This is the formula that you typically use for a confidence interval for sigma squared. But this interval actually performs rather poorly. What I mean by that is, when I say that I have a 95% confidence interval, often it's a lot lower than 95% true confidence level, the coverage level. You can do a little Monte Carlo simulation to prove it to yourself. The only time this ever works well is if your data has a normal distribution. How often does your data have a normal distribution? Well, you'll never know for sure unless you're simulating the data. But even if you use like a distribution like a logistic distribution, if you're not familiar with the logistic distribution is symmetric, just like a normal distribution is. If you use a logistic distribution and you say you want a 95% interval, you're not going to get a 95% interval. It's going to be lower. Anyway, if you want to know about alternative intervals, I can talk about it at some other time. But in order to derive this confidence interval, you have to start with this. So like in your proof for your confidence interval, you're going to need to start off saying, hey, I have my y1 through yn distributed independent normal mu sigma squared. I want you to be that formula. In this context here, what one can do is show that, let's say I have a random variable x squared. So this is a capital letter. One can show that n minus 1 times a capital S squared over sigma squared has a chi-squared distribution with n minus 1 degrees of freedom. So just like in the assignment, I say that T has a T distribution, x squared has that distribution. So in the assignment, I want you to assume that T has a T distribution. You don't have to prove it. So here, I'm not going to prove this. Now the main part of then the proof comes as follows. Since I know that x squared has a chi-squared distribution, then I can say that 1 minus alpha is equal to the probability that x squared is between 2 quantiles from a chi-squared distribution. The alpha divided by 2, n minus 1 degrees of freedom quantile, and the 1 minus alpha divided by 2 quantile from chi-squared with n minus 1 degrees of freedom. I know that because x squared has a chi-squared distribution to it. So then the next part of my proof is, okay, let's see if I can get sigma squared in this expression somehow. So 1 minus alpha is still going to be equal to the probability of chi squared alpha divided by 2 n minus 1 is less than n minus 1, a capital S squared over sigma squared is less than chi squared 1 minus alpha divided by 2 n minus 1. Okay, good, I got sigma squared in there. Now, where would we like sigma squared to be? Well, take a look at our expression up here. We would like it to be alone, all by itself, in the middle. So, next step, equal probability. Let's invert this. So I got a sigma squared n minus 1 s squared. What's going to go on the right-hand side?
What was on the left?
What was on the left side but the reciprocal. So 1 over, sorry, I'm running out of space here, chi squared alpha divided by 2, n minus 1 degrees of freedom, 1 over chi squared, 1 minus alpha divided by 2, oops, yeah, n minus 1 degrees of freedom. Sorry, it's getting messy. Okay. So what's the next step? Well, equal, let's see, so that's 1 over chi squared, alpha divided by 2, n minus 1. I just moved that n minus 1 and that capital S squared over to the different sides. Okay? I'm almost there. I'm almost done. Is this my confidence interval? No. The key is that, well, can you ever calculate S squared there? No, it's a random variable. So, then I could say something like, well, by substituting, I'm going to write this kind of faster, by substituting observed values for random variables, we obtain the 1 minus alpha times 100% confidence interval for sigma squared as n minus 1, a little s squared over the chi squared quantile is less than sigma squared is less than n minus 1, little s squared over the chi squared quantile. And that's your proof. You basically need to do the same thing now with the t-distribution. What this is going to do is give you some experience, again, using LyX for this. Let me take a look at my notes here. So your derivation should include paragraphs of text because, you know, when you do a mathematical proof, it's basically, you know, it's a paragraph. You just have some equations in there with inline and displayed formulas. So this is an example of a displayed formula. This is an example of an inline formula in Word. Include at least one cross-reference to an equation. So you might have to say something like, in equation 1, or using equation 1, we obtain, you know, something like that, and at least one multi-line equation. You know, well, look what I was just doing here. Looks like I had some multi-line equations. Right here. Okay. So turn in your LyX file, the PDF created from this LyX file as well. And organize all this together in one nice zip file. And do not plagiarize the derivation from the book. You know, this stuff's in textbooks. You know, don't plagiarize it. Write it basically what would be at like the level, and this is what I tried to do here, of a set for Stat 380. Now, Stat 380 is an introductory statistics course, often the very first stat course an undergraduate will have, just from a calculus perspective. So the difference between, for those of you who are actually involved with Stat 218 here. The difference between 218 and 380 is 218 done a calc prerequisite, 380 you do. And so, you do a little bit of different things. Are there any questions? Okay, then lastly, number 4 here. Construct a presentation with Beamer and LyX that can be used to illustrate the write-up from problem number 3. So imagine, let's say, I was teaching Stat 380 here, and I had all my, I was going to do this proof in class. And what I could do is create a Beamer file for that, or Beamer presentation file, where I actually go through step by step that proof. And so those different steps, what does that mean in terms of doing a presentation? You're going to have animations. So you're going to have multiple slides within a frame. We haven't talked about how to do the animations yet with Beamer, but we will next time. And so the way that I want your presentation file to be structured is that you have 4 frames in total, where you have more than 4 slides. And the first frame, give me your title and author. Second frame, do like the first part of a write-up of this derivation from 3. The third frame, continue with that derivation. And then frame 4, and this is often a very good way to always end any kind of presentation, is that you simply have that title and author information again. So make sure to properly use tools in LyX available through Beamer to construct the presentation. Turn in the LyX file. There's going to be, you understand what a handouts file and an animations file is from next time. And organize all this stuff together in a zip file. So that is assignment number 3, or assignment number 4. Are there any questions? Okay, then that is all for today.